Autograph offers a wide range of functionalities for working with EXR passes generated by 3D render engines. In the Autograph welcome page, and more specifically in the Assets section, we can see the Freeway project based on a sequence of EXR images created with Blender and more specifically with the Cycles render engine. Based on these passes, we will be able to simulate a wide range of optical effects such as motion blur, defocus, or a distance-based fog. Clicking on the Download and Open Project in Autograph button will retrieve the EXR sequence. The Freeway folder can be imported into Autograph by dragging it directly in the project panel. The sequence now appears as a new project item. Double-clicking on this sequence displays it in the viewer. Selecting this item in the project panel takes you to the reader options and especially the output parts parameter. This contains the three available passes: color, depth, and motion vectors. This image has been recorded in 32 bits per channel to maintain the highest quality. Autograph's renderer also works in 32 bits per channel, and even if the sky appears to be completely white, by using the eyedropper and moving our mouse over the image, we can see that some values are way above 1. The viewer contains 3 post-process parameters that simulate a diaphragm shutter, helping to recover details in the sky. Pixels whose light intensity is greater than 1 are not visible. This processing is only applied to the viewer, but we'll see later that similar processing can be applied to a layer. To quickly create a composition from an EXR sequence, simply right-click on it and choose Create Composition from EXR passes. This will create a composition with exactly the same name as the sequence. As the EXR sequence contains 3 passes, we can see that 3 layers has been created displaying color, depth, and motion vectors. Inspecting the sources of each of these layers, we'll see that they all use the same reader. However, the output parts parameters has been unshared so that it can be overridden locally to point to a given path. To quickly assign a different path to a layer, simply go to its source parameters and then to the reader's output parts parameter to choose another path. This is exactly what Autograph will do when creating a composition from an EXR sequence. Here, however, we'll choose to work from a composition containing only the color path. Let's delete the current composition and drag the project item into the empty timeline to create a new composition of the same size and duration, using by default the output part currently set by the reader. We are now going to build our project from these different passes. We'll start by using the depth path to simulate a fog that spreads progressively from front to back. This effect can be created in many different ways, but here we'll choose to use a new constant generator. A new layer using this constant as a source appears at the top of the stack. We now connect the reader in the project panel as a mask for this layer. For now, let's hide the layer containing the color path. Click on the mask in the inspector to access the reader parameters. This takes us to the output parts parameters when we can select the path we want to use as a mask. Note that the depth path is labeled point V, which means that it contains only one channel. When a single channel image is mapped to a viewer that can display up to 4 channels, it's mapped to the red channel by default. We can switch the viewer to red mode to inspect the depth path. However, a mask input is based on the alpha channel of its source in order to define transparent and opaque areas. So we need to reroute it from the red channel to the alpha channel. The modifier used for this is called Shuffle. It allows us to replace the alpha channel with the red one at the output. The constant is now semi-transparent according to the red channel injected into the alpha channel. This can be seen by displaying the checkerboard in the background. When the layer containing the color underneath is shown again, a fog appears extending from front to back according to this depth information. The layer's opacity can be changed to make the addition of this fog above the image more or less visible. But before doing this, remember that the depth pass produced by cycles is not anti-aliased and therefore produces this kind of hard edges. To overcome this problem, there's several methods we can use. One of them is to add blur to this layer to make the very steep contour edges a little less noticeable. This workaround is even less visible when we reduce the layer's opacity. This opacity value is usually very low. Let's finish by increasing this opacity a little to talk about the constant color. By selecting the source, we can click on the color parameter to change the hue of this fog. Click on the colored circle to keep the constant a blue tint, then reduce the opacity. The addition of a fog according to depth is generally very subtle and allows you to reduce contrast according to distance from the camera. Let's now have a look on how to add motion blur depending on the movement of camera and objects. But first, let's rename these two layers: car for the layer below and fog for the layer above. The following effects will be added to an adjustment layer, allowing you to add multiple modifiers to the entire stack below. Let's select this adjustment layer and add a new vector blur modifier. Its motion vector source parameter is set to generated mode by default. This mode will analyze previous and next images to generate a blur based on the pixel displacement from one image to another. The motion estimation section displays a large number of parameters for setting up this analysis. The default settings do not always provide a finely tuned analysis, and a movement in the opposite direction, such as a car, can cause quite visible artifacts. Instead of using generated mode, we're going to use custom mode, which allows us to provide motion vectors. Instead of trying to detect pixel movements, we're going to use the vector path given by the EXR sequence, and which contains the true motion data. Let's select our adjustment layer, select the vector blur modifier, and connect our reader to the custom motion vectors parameter. Having connected the reader to this parameter, it appears in the selection overview at the very top of the inspector. Click on the source and check that the reader is pointing to the vector path. The modifier now uses the motion vectors stored in the vector RGBA path to produce a blur which may not appear to be correct, but at least is stable over time. The vector blur modifier must rely on the forward vectors to produce a correct motion blur. Cycle stores this information in the blue and alpha channels. As the vector blur expects to find this information in the red and green channels, we'll have to use the shuffle modifier again. This modifier is added to the source used by custom motion vectors to replace the red channel with the content of the blue one and the green channel with the alpha channel. The vector blur produces too much blur, but we can see that at least it's heading in the right direction. And more importantly, we no longer have any artifacts when the two cars are crossing each other. Let's go back to the vector blur modifier and access the amount parameter, which we are going to reduce in order to lower the blur intensity. Let's start by setting this value around 0.05. Scrubbing the timeline, we see that the vector blur increases the realism of our sequence. We simply need to deactivate and reactivate the vector blur modifier to see its effect. Zooming in the front of the car, we can see that a ghosting effect surrounds its silhouette. By increasing the motion vector's blur parameter, we can make this artifact disappear by blurring the vector path, which is also not anti-aliased. Doing this also greatly improves the quality of intersections between the car and the pillars when the car is moving in the background. Using the motion vector path provided by your renderer, in this case Blender Cycles, allows you to create a much more precise blur, but also a much faster one. The amount value will depend on the shutter speed or shutter angle of the camera you want to simulate. Autograph's vector blur is fully accelerated by your GPU, enabling extremely fast calculation for enhanced realism. This effect on the graffiti on the wall is especially visible here. Now we have simulated motion blur, let's talk about depth of field. Whatever the distance of the objects from the camera, they are now equally sharp in the foreground and the background. But before applying this effect, let's select the adjustment layer and press the Enter key to rename it FX. To focus on this depth of field, let's disable the vector blur in the selection overview. Let's use the same adjustment layer to add all the effects. We can now add a Defocus Modifier. This modifier is made up of a large number of parameters. This of course includes the defocus intensity, the iris shape simulating the camera, but also the number of samples affecting the defocus quality. Increasing the defocus value will blur the whole image more and more, but the defocus intensity can be controlled per pixel by connecting the source to the depth map parameter. Once again, we're going to use the same reader with the output part parameter set to depth. Select the adjustment layer again and click on the Defocus Modifier. Drag the reader from the project panel to the depth map connection slot. This connection will appear in the selection overview and can be selected to edit its parameters. The defocus applied to each pixel is now controlled by the depth path. Let's push the defocus parameter to 40 for a more visible effect. By switching the focus mode to depth value mode, we can specify the distance at which we want to focus on the foreground or the background. Let's animate the focus depth value over time, so we can constantly focus on the license plate at the front of the car. We keep the defocus value at 40 to increase the effect. We create a first keyframe on the focus depth parameter and then press the U key in the timeline to display all the keyframes. Let's move to some specific time in the animation to change the focus depth value and keep the focus on the front of the car. The goal here is to animate these parameters with as few keyframes as possible. By default, keyframes in Autograph are added in smooth mode. This means that when we add keyframes, the interpolation between them will not be linear, but will be progressive, with accelerations and decelerations across time. 7 to 8 keyframes should be enough to cover the entire animation. Keeping a high defocus value along the animation helps you to check if the focus is done at the right distance. The focus plane range parameter lets you adjust the gamma of the depth path to make it less linear and focus on the whole car. We can now reduce the defocus value to 7 pixels. The depth of field has been reduced to only focus on the front of the car. We can now reactivate the vector blur. In fact, we are going to reorder the modifiers, so the defocus will be applied first, followed by the vector blur modifier. Let's now simulate the light diffusion through the camera lens, especially in the darkest parts, such as when the car is under the bridge. Let's add a new glow modifier to the adjustment layer based on the very high values of the pixels covering the headlights to generate this halo. By disabling the glow modifier and using the eyedropper, we can see that the pixel's brightness is very high. Let's reactivate the glow and increase the size parameters to see that we have a pixelated effect around the halo. This is due to the fact that the glow is made of several halos, one on top of the other, whose resolution is reduced as the blur becomes more and more important. Increasing the downscale threshold reduces these artifacts. Switch the filter to quadratic to produce a much more diffuse halo. Then reduce the gain value to make the halo dimmer. We're going to reduce this value to 0.001. The high light intensity produced by the glow is due to the fact that the initial pixel value was also very high. For this reason, the glow value must be precisely adjusted using the left and right arrows on the keyboard, then up and down to increase or decrease the value under the cursor. The gain value currently set in single mode applies evenly to the red, green, and blue channels. However, switching these parameters to separated mode allows you to access both parameters separately. So you can change the halo color to give it a violet hue, even if we prefer to return to a bluish color here. Glow expansion is computed linearly by default, but by adjusting the gamma parameters, you can concentrate the light intensity around the headlights. For the time being, we've added a defocus, a vector blur, and a glow to this adjustment layer to add even more realism to the original rendering. To continue in this way, we can grade our shot using Grain Modifier. As Autograph's render engine also works in 32 bits per channel, all pixel intensities and precision are preserved. This means that the grade can be used to retrieve information from the highlights and bring it back into the visible range, or to brighten up areas that are too dark without adding noise. As we mentioned earlier, each of these default parameters in single mode can be switched to separated mode to act differently on the red, green, or blue channels. The grade can be used to change the shot color, but Autograph offers a number of other modifiers for more precise work. Most of them start with the name color, but there's also the OCIO Look Transform modifier. This modifier contains several presets and is designed to emulate the colorimetry of different films. There are several types of contrast for the filmic view transform. Then we find a list of several films designed to simulate their immersion. However, when we use these presets, we see that pixels whose intensity is greater than 1 produce artifacts. To limit the pixel intensity to a maximum of 1, we can use the clamp white option of the Grain Modifier. We can check the effect of this parameter by using the eyedropper and seeing that the maximum pixel intensity in the 3 channels is now 1. Without this option, pixel intensity would be much higher. Switching on clamp white allows you to limit the maximum intensity to 1. This constraint can also be achieved by adding a clamp modifier. Placing it just before the OCIO Look Transform modifier limits the pixel's brightness. This modifier acts in exactly the same way as the clamp white option in the Grain Modifier, so we can rely solely on the grade and remove the clamp modifier. When this clipping has been set up, we can use one of the presets available in the list. It's going to change the brightness, the contrast, and the color. The Kodak Ektachrome series will offer high contrast and saturation. The Ektachrome 6040 will also offer warmer colors. Going back to the Grain Modifier allows you to adapt the brightness of the image to match the preset used. All modifications made in the Grain Modifier are computed in 32 bits per channel. The clamp white option we've activated will only be applied after the grading operation is being performed on the original image. This means that we always have the ability to recover information in the highlights or boost pixels in dark areas. But Autograph can also use a reference image to replicate the colorimetry of a shot. Let's import an image from the Matrix Reloaded movie. Start by deleting the OCIO Look Transform modifier and also the grade to get back to the original color. To also view the reference image in parallel, double-click on it using the Control or Command key. This image is connected to the viewer's secondary slot so that the two images can be compared. The reference image is smaller than the format defined by our composition, and the separator can be moved and rotated to give more space to one of the two images. Let's select the adjustment layer and add a new color transfer modifier to the list, which will take a reference image as input. We drag the matrix image from the project panel to the reference parameters generator slot. The whole animation is now replicating the color coming from this reference image. Unlike the film presets we previously mentioned, Color Transfer Modifier supports pixels with an intensity greater than 1 and does not require the addition of a clamp modifier. Disconnect the reference from the viewer's secondary slot and close it. Among the color transfer parameters is an output saturation parameter, which we need to reduce to compensate for the fact that our shot is much brighter than the reference image. The mix parameter blends the color-corrected image with the original one. To change the grading of this shot again, we simply need to import a second image, such as this one, with a much wider color palette. Just select the adjustment layer and select the color transfer and simply drag this image from the project panel onto the reference slot. The extremely saturated colors of our reference image are now reflected in our animation. We now get back to the color transfer parameters to reduce saturation again while adjusting the mix value. Color transfer will act on the image by trying to find correspondences between the reference image and the shot, in terms of luminance as well as color hue. That's why the lower luminance of the blue sky will not be used to match the sky in our animation. By undoing the last connection, we return to the matrix grading. To give our sequence an even more cinematic look, let's finish by adding a film grain modifier. Two methods are provided for this one. Fast mode superimposes random noise on the image. By default, this noise is different for each image. The mix parameter reduces its intensity to make it less visible. The grain intensity is controllable for each channel. You can also apply a per-channel blur or switch this parameter to single mode to control the blur with a single value. The main advantage of this mode is that it includes a large number of parameters, but above all, it's fast to compute. However, there is another mode named Precise. This much more advanced mode simulates the light transport through the grain of a film. By increasing sample's value, we control the grain density inside the film. Let's choose 150 for now. We can also define the grain size. Grain diffusion will influence the light absorption. The higher the value, the darker the image. The smoothing value increases the light's refraction through the grain, blurring the image. These parameters are designed to simulate all types of film with different grain densities and sizes. For now, let's set the smoothing value to 0.9 and increase the number of samples to 180. Reduce the grain size to 0.02, and finally let's reduce the mix value to make this grain less visible. With the Vary with Time option activated by default, we can see this grain will be regenerated at each frame with a different result. Depending on the color, the light intensity and the contrast, the grain will be adaptively regenerated. We'll stop here with the compositing of a shot, to which we've already added many elements that increase its level of realism. We've added motion blur, defocus, distance-dependent fog, color processing, and the simulation of a grain inherent in the use of film. For a better comparison, let's press the Ctrl or Command key and double-click on the source, switching the output part back to combined RGBA mode. Here, we can see the huge difference made by the compositing. Thanks to all the tools provided by Autograph to work with OpenEXR 5 sequence.